Hello again, this is Dr. Kern. I'm here with Dr. Johnson. Say hi.
Hi.
Who you've already met as well. And we're going to talk today a little bit more about limits, but a little bit different than you've seen before, or that we've talked about before, as it turns out. So now what we're going to do, before you may remember from last time that we talked about things that look like the following. So basically, if we had the limit as x goes to 1 of x, well, we saw that last time that was just going to give us 1, and it doesn't matter what number that is. We also saw that if you want to take the limit of some constant, it doesn't matter. You can choose 19.1 if you wanted to. And again, it doesn't matter what x goes to. Say x wants to go to 5. Well, the number is just a number. And remember, if a function is a number, that's just a straight line. And so we know it's never going to change from that. So it's just going to be whatever that number is. And we saw that last time. So these are basic limits, but they're also part of what's called limit laws, which is what this video is about. And we're going to actually do 2 videos. So this is kind of like part 1 of limit laws. And the idea behind this is that while it's great to have tables and it's great to have graphs, that's a really great way of seeing what the limit is, sometimes it doesn't always give you the precise answer of what something's going to look like. And sometimes when you see a graph, things seem to be missing. If the graph isn't exactly perfect, really important things can be left out, even if you're using a graphing program or your graphing calculator or things like that. So sometimes you have to go and take it from an algebraic viewpoint about what's going on. And so that's what we're going to talk about today. So we've already seen, so these are the first 2, the basic ones. And one thing to keep in mind as we're going is that the limit laws work, but maybe there's circumstances in which they don't always work. So in this video, they're mostly going to work. So we have these 2 here. But what if we had something that looked like this? So I'm going to use t in this case because we have to get used to using different variables. So let's say I have the limit of t plus 3 as t goes to 2. So when you take a look at that, in an ideal world, what would be the easiest and nicest thing to happen if we wanted to say, like, well, how do we take the limit of t plus 3? What, Dr. Johnson, what do you think would be your favorite thing in an ideal world?
I mean, it'd be great if we could just plug it in, if that wouldn't cause any problems.
Well, we have to see. That would be really nice. It'd be really easy. And so how can we make it so that it would work when we have a sum? Well, one way is to say, like, well, can we split it up? Because if we split it up, then the first part is going to be like this first term that we looked at here, and that we just substituted whatever the value of x was. So as it turns out, when we have a sum, the way that we deal with it is we split up the 2 parts. And so you see here, we have the part that's just t and the part that's just 3. So it's sort of like we can distribute it, right? We have to be a little careful about what we called it, but we're basically distributing the limit. And then, well, we know the first part from the first thing that we did up here. Well, that's just whatever the t value is going to, that's 2. The second part, it's just a number, so we can do whatever the number is. And that's exactly like as if we substitute in, like Professor Johnson said. So there we go. Great. That's awesome.
Yeah. So just one thing from what Dr. Kern was saying earlier about the limit laws sometimes being useful, right? They're always true, but sometimes they apply and sometimes they don't. And this is a case where they're super useful because we can split up the sum into 2 parts because both of those individual limits existed. So while the limit laws are always true, sometimes we have to use different tools in our toolbox. And that's one thing that Dr. Kern is going to show you today.
Well, one other thing that we have to think about is instead of doing adding, what about this one? I'm going to do x going to 1 of x minus 4. So if we apply this same sort of thing, should it be any different if we're doing a difference as opposed to a sum? Do you think it's going to make any difference here? Well, no, because remember, subtraction is pretty much the same thing as addition. You're just adding a negative value.
Exactly.
So the way to think about it is just doing that same thing, which is what I'm going to do here. Now, some people do this in different ways. Some people like to put just a minus sign in the middle, which is I'm going to do that too, because I think it's easier and it makes sense. But other people would say, let's add the limit of -4. And that's okay too. Both ways work fine and they give you the same sort of answer. Now, what do you think? Once you do this once or twice, I don't know, would you really do it this way? Would you split it up? I wouldn't.
Yeah.
Would you, Dr. Johnson?
No, I mean, I think it's good to do it a few times because then you remember when you're allowed to do it and when you're not allowed to do it. With constants, addition, subtraction, it's really not as important as when we get later to quotients and powers and things like that, that you have to be a lot more careful about whether it applies or not, whether or not you can even use the law. But in this case, after a few times, yeah, I would just sort of jump ahead a couple steps and sort of go straight to plugging it in.
Right. So I think in this case, you could do it. So if, as I erase this, what's on here already, just be aware that it's usually going to be a lot easier that you can just do everything really quickly. Okay. All right, so let's try something a little bit different. So we've done addition and subtraction. So I want to do one more thing in this video, and that is something that looks like this. So let's do the limit as x goes to, let's say, -1 of 4 times x. Okay. So this is a number, this is the function for x, so it's a number times x. So we haven't come across this particular version before. So again, in an ideal world, what would make it easier for us so that we could use things that we already know? What would be
It'd be great. It'd be great if we can split it apart, just like we did when we were adding.
Right, it would be. And because that what's in front of the x is just a number, the nice thing about it is, by splitting it up, basically we're just, well, there's two ways of looking at it. It turns out that, that we can actually just split it up, and I'll do parentheses. Mm-hmm. Sorry, I have to put this in another line because I'm writing too big.
No worries.
We can just split it up. It's actually really nice. And we've seen both of these two things before. So the number just goes to whatever the number is. And the limit of x as x goes to -1, well, it's already telling us once we say it out loud what it's going towards. And that's really straightforward. And you can see, again, it's kind of the same thing as we saw on the last screen. And that is that it's the same as if we're just substituting in. The advantage, note though, that another way of thinking about this is, let's do another example here. Let's say 7x. One thing that you can think of this as doing is basically you're taking the constant outside of the limit. And this is going to be useful not just now, but when we see slightly more complicated things later on. If you have a constant coefficient, you can just take it outside like that. And that's always going to work as long as you're multiplying by a constant. So this is a little bit of an easier case. And we get 35, which should be right if I remember my multiplication table. But other than that, so what we saw here is we saw 5 different limit laws. The first 2 were the basic ones that you saw from the previous section. And from there, we built up 3 more on addition, so the sum, the difference, and multiplying by a constant. So far, nothing has been really too surprising, and everything that we've done, we haven't really seen weird cases in which like, oh, we won't be able to apply that law. But
Right.
there are cases like two, and so when we see a few more limit laws, we'll see that sometimes this doesn't always work. So there we are.